All right, so today we're going to be talking about solving right triangles. And all that means is for every triangle, we have three angles associated with a triangle and three sides associated with a triangle. So solving right triangle just means finding whatever missing angle or side that we see. So we're going to use trig to help us find missing side, and also we'll use trig to find missing angles. So we'll start off with finding missing sides. So example 1 here, find the missing side length using trig, solve for x. So the first thing we want to do is we want to be able to identify the angle that we're starting from. Okay, we never want to use the right angle. The 90-degree angle is not going to be helpful as we build our trig. So we want to know where it is, but we're not going to start with that. Now, we have one angle here that is that's visible for us to see. So let's go ahead and start with this angle. I'll put a box around it to indicate that this is where we're basically standing, okay? And we're looking at the rest of the triangle from that perspective. All right, so I want to find the missing side. Anytime I'm finding a missing side, I can use SOHCAHTOA here. But we have to decide which trig function to use. So let's look at the parts of the triangle where there's information. Okay, either a number of values given or the unknown variable we're solving for. Okay. So if I'm here at 62 degrees, what's the 25 in relation to this 62? Opposite, okay. So this opposite, and then the x is part of hypotenuse, right? So which trig function will be the best suited one for this problem? Sine. Okay, so we're gonna use sine. So it's always sine of an angle. In this case, sine of 62 is equal to opposite over hypotenuse, equals to 25 over x. Okay. I like to set it up this way. Leave a space beneath sine 62 because I can put a 1 underneath it. And now I'm just going to cross multiply until I get to solving for x. Okay, so I'm going to pair the diagonals together. So I get x sine of 62 is equal to 25. Everybody okay so far? Okay. X sine. Now, sine and 62, that's one thing, right? Sine is never standalone. It's always sine of an angle. So that sine 62 is one. It kind of all goes together. So what can I do to solve for x? Yeah, divide, right? Divide both sides by. Yeah. So insert into your calculator. Whether you're using graphing or scientific calculator, you do want to make sure that your mode, you're in degree mode, okay? And that you're not in radian mode. So if you click on the mode button, just make sure that the degree feature is highlighted. If not, you can just scroll over and hit enter. Okay. Go back to your home screen. You can do second mode, which will go back to your home screen. And we're just going to round to 2 decimal places. I'll specify on the quiz or test How many decimal places to round to? Okay. How many of you guys are using a graphing calculator? Raise your hand. Okay. I do want to show you a feature here in case you don't know this one here. So mode, you want to make sure that you're in degree mode. I'm not, so I have to go and click on degree mode. Second mode, we'll go back to your home screen. Now I can do 25 over sine 62 using a division sign, okay, which is fine. There's also a nice feature here where it'll have the math print that you did on that you see on this scientific calculator. So if you hit alpha y equals, there's going to be that n over d feature. So alpha y equals n over d, and that's going to pull up this nice fractional feature that that's a little bit cleaner to look at. So again, alpha y equals n over d. But if you're just using a scientific calculator, then it has that n over d feature right there. Does anyone have any questions there about the graphing calculator and get into that? If you don't have to use it, but it's just a nice feature to have. It should be in degree mode. Degree mode, yeah. Okay, so via graphing calculator, you can go to mode, and then you can scroll down to that degree. You see that? Oh, okay. Yeah, so. Okay, so that's how we find a missing side. Question. Yeah, just take a pass with you. All right, any questions with one? Okay, eventually we're going to solve the entire triangle. I mean, it gets easier from here. If I want to find a missing angle, I can use subtract 180. If I want to find the other missing side, I can use Pythagorean theorem. But we're just going to focus on the hard parts, or the most the parts that requires a bit more work. So I want you guys to try number 2 and approach it from the same steps that we did, right? Put a box or circle your angle so you know how you're going to name each of the sides of the triangle, because your opposite and your adjacent is dependent on where your angle is, right? And then identify the sides in relation to that angle, and then you can decide whether you're using sine, cosine, or tangent. And then once you set up your equation, force it into a fraction equaling a fraction, pair up your diagonals, and then algebraically get x by itself and solve for x. So which trig function do we end up choosing? Tangent. Okay, good. So opposites from that 39 degrees is the x. Adjacent to that 39 is the 8. Pair the diagonals together, set them equal. In this case, we don't have to divide anything. The x is already by itself, so we can just simply insert into our calculator and find our length for x. Any questions? So if one angle is given and one side is given, you can always find a missing side using this strategy. However, if none of the angles are given except for the fact that it's a right triangle, we're going to set up the same way, but the way that we solve for the angle is going to be a little different. Okay. Anybody have any questions with 1 and 2? So if you look at number 3 here, notice that we don't have an angle given, right? We have 2 sides, which is going to be helpful, but we don't have, we know there's 90 degrees, but we don't know what the other 2 angles are. But we're still going to approach it the same way initially. We're going to put a box around that theta to indicate that we're starting from this angle, and we're going to name the sides based off of that angle. So let's see what we can use here. We're going to involve 12 and 16 because that's information that's going to be helpful for us. So which trig function can we use that will hit the 12 and the 16? Cosine, yeah. 12 is adjacent, 16 is hypotenuse. Cosine will allow us to get that 12 and 16. So we're going to set up here. Cosine of theta is equal to 12 over 16. Now, notice that we're not trying to find a missing side here. So if we cross multiply, we're not really going to get far because we're not finding missing side, we're finding that theta. But a little bit complicated here because theta is inside cosine. So it's not as easy to just remove that theta away from cosine. So what we have to do is we have to involve inverse cosine. So inverse cosine will allow us to basically release that theta away from cosine, get that theta by itself. So let me show you the long way of doing this. We're going to take the inverse cosine of both sides. And I'm doing the long way right now to show you that we're basically doing the same thing on both sides. We're basically undoing that cosine on the left side, but whatever we do to the left side, we're doing to the right side as well. So what's going to happen here, the inverse cosine of cosine is just going to wipe each other out, leaving me with just theta. So we don't want to think of this as dividing by cosine. We're not dividing by cosine. We're basically, we're moving this cosine to the other side, but in order to move it, we have to involve inverse cosine. So basically, that when that theta is by itself, we undo this cosine to the other side, which involves inverse cosine. So we're going to make the calculator find that angle for us, but there's a slightly different button that we need to find, that we have to use. You see how on your scientific calculator, there's this cosine inverse, that cosine -1. We call that inverse cosine. So you're going to hit the button twice. Tap it twice, and it'll get to that inverse cosine feature. Fractional button, 12 over 16. Now this is a degree measure, so 41.41 degrees. I'll show the steps for the graphing calculator in a second. In the graphing calculator, in order to get to that inverse cosine, you see how the inverse cosine is in the blue above the cosine button. So you got to do second cosine. Second cosine. And then if you want to do that fractional time math print feature, you can do alpha y equals option 1 n over d 12 over 16. So anytime that we have a missing angle that we're solving for, we set up the same way. We use sine, cosine, or tangent. But then the next step is we got to isolate that theta. We don't divide by cosine, we don't divide by that trig, but we move it. And when we move it, it's involving inverse cosine or inverse sine or inverse tangent, depending on what we start with. Okay, go ahead and try number 4. And I'm going to walk around and just make sure that you guys don't have any questions. Okay, looking good. What I saw. Guys, if you don't want, you don't have to show this step on the quiz or test. I just want to kind of convince you why there's an inverse cosine involved, because we have to basically undo that cosine to release it from that theta. So if you want, you can just go from here, jump directly to theta equals inverse cosine. You don't have to necessarily show the step. I just want to convince you how we got to that point. So you don't have to show that step. Okay. So if I want to find the missing side, set up my two fractions, cross multiply, and solve for x. If I want to find a missing angle, I need to involve inverse sine, inverse tangent, or inverse cosine. Okay. All right. Any questions? Okay. So now we're going to put it all together because depending on what's needed, we have to basically decide how we want to approach the problem. And sometimes I think sometimes students get stuck because there's almost too much information given. And if that's the case, then you can choose which one you want to use, sine, cosine, or tangent. And we're also going to go one step further, where we're going to try to find all the missing sides and all the missing angles, but we have to decide which one to do first. Okay, so that kind of adds to the complexity, because we're not told directly what to do first. We got to look at the triangle and decide what is going to be the first thing that we take care of. Okay, no questions, 1 through 4. All right, let's look at number 5. So now we're asked to solve the triangle. Okay. Solve the triangle. Let's look at number 5. Now, number 5, we don't have any angles given except for that 90-degree angle. So we know that we have to involve inverse trig in order to get to angle A or angle B. But here's where we have some decisions to make, right? We can either solve for angle B or solve for angle A first. Okay? It doesn't matter which one. I'm just going to target angle B, okay? But you can easily do this with angle A. But we only do this once, Okay, because after we solve angle B using trig, we can rely on an easier method to find angle A. But again, you can choose. You don't have to do angle B first. You can do angle A first. But just so that we can just stay together, let's just do angle B together first. So if I want to target angle B, which trig function is most appropriate? Okay. Cosine. All right, cosine. Yeah. So adjacent over hypotenuse. Now we could use tangent. We could use tangent and find this missing side using the Pythagorean theorem, and then go through tangent. So there's that option as well. But I'm just picking the easiest one for me to use, and that's going to be cosine. Because otherwise, I got to find that missing side. So I'm going to target using cosine. Cosine of B equals 7 over 11. I have to do inverse, right? Cross multiplying is not going to get us there. That angle B is stuck inside cosine. We got to release that angle B away from that trig. Okay, what did you guys get for angle B? Okay, 80.48. I'm going to just notate it on my triangle so I can clearly see it. So now the rest of the triangle gets a lot easier. Okay, this is the only hard part. The rest of it we can rely on previous methods that are more familiar to us. We don't have to rely on trig from here. Because if I have two angles of a triangle, I mean, I can use trig to do A, but what's an easier way? Once I have two angles of a triangle, how can I find that third angle? Yeah, I can do them all 180, right? Because I know that three angles of a triangle has to be 180. If I'm missing two, I really can't do that process. But if I have two out of the three, it's easy to find that third missing angle. So we know that angle A is just 180 minus this angle minus this angle. Okay, is that clear? I'll find angle A. Now, there's another way that I can find angle A. I don't have to go through this process. I can just involve a different sum, because this is 90 degrees, right? Which means that angle A plus angle B must add up to be what? 90 as well, right? If this is 90, then the other 90 is going to come from angle A and angle B. So another way you can do it, they say angle A is just 90 minus 50.48. Because we know that if I just take the 90-degree out of the equation, I know that my other two acute angles must add up to be 90. That's another way to get to your angle A. Okay. Almost there. We want to solve the triangle, which means that we need to find all three angles and all three sides. What's the last missing piece that we need? Yeah, AC. And I can find AC by using what? Pythagorean theorem. Yeah. Pythagorean theorem. If I have two missing sides of a triangle, right triangle, I can use Pythagorean theorem to find that third missing side. I want to give it a variable name and call that x. You don't have to reduce it. I think the scientific calculator can reduce it for you, but root 72 is fine. Okay, so here's a strategy for solving a right triangle. First thing you do is decide what you want to find first. Do you want to find the missing angle using trig, or do you want to find the missing side using trig? Sometimes there's more than one option in front of you, and you kind of have to just kind of pinpoint which way you want to start. But once you apply trig once, the rest of the triangle, you can use easier methods. You can use Pythagorean theorem to find the missing side, or you can use 180 to find the missing angle. Any questions? All right, can you guys try number 6 and see if you can decide how you want to start this problem? You only need to do trig once, and then the rest of the information you can use an easier method. Try number 6. So sine 37 is opposite of sine. So what's opposite? Right. The one that underneath it cross multiply. So here, we can't start off with the sides because we have too many missing sides. We have to rely on sine to get to the side. Yes, so sine 37. That's a show it. Right. I'm gonna walk through it. Guys, I just wanted to walk around and make sure that you guys are comfortable with this. It looks like you guys are. So we have a quiz on Friday, but I like to spend additional time with word problems. I think those are the messier ones. So I had classwork, but I'm going to just save the classwork for us to do tomorrow. And I want to have an extra day for us to let the word problem sink in. Okay, so but it looks like you guys are good solving triangles. I don't see any issues that you guys have. Maybe we'll get some additional practice tomorrow, but looks like you guys are good. You guys feel that way as well. Okay. All right, good. So okay, I'm going to just pull a couple of word problems for us to try. I think I think in general word problem is just feels kind of daunting because you just don't know where to start. But the strategy for these word problems is that it's going to involve a right triangle. So just see if you can draw a right triangle that fits the description in the problem. Okay. So let's try number 28. Okay, this is on page 8. Okay, so let me read this problem here. Brad built a snowboarding ramp. So we know a ramp is slanted, right? So that's some indication there. With a height of 3.5 feet. So height is referring to a vertical component of the triangle. 18-degree incline. So that's going to be the bottom corner of the triangle as the ramp is rising. So here's my triangle that will fit that description. Draw a diagram representing the situation. The height is 3.5 feet. So when you see the word height, you know that's a vertical component. Incline, so that's going to be where you see your triangle rising, beginning to rise. Okay, so that's the information that I have right now. Are we okay with that? Okay, good. That's a diagram from part A. For part B, determine the length of the ramp. So are we going to be solving for this horizontal side or the hypotenuse? Hypotenuse, right? Ramp, we should have to understand that ramp is slanted, right? So that's going to be where the missing information we're looking for. Okay. So that's the hard part of word problems. Just being able to draw the picture from the description. And now it just feels like a problem from the previous page. Okay, so see if you can solve for x. Solve for x. And use trig, right? Either sine, cosine, or tangent. And then we'll just move on to the next word problem. The next word problem, we're gonna skip 27 and the bottom of the page because I find that some of these problems are either hard to see or the description is not very clear. So let's finish 28 first, and then we'll just try to get more word problems under our belt so that we feel like we have 2 days of word problems, and then be a lot more comfortable for Friday's quiz. Okay, questions? All right, let's go to page 10. Okay, this is the middle of the page here, page 10. Trig ratios have many practical real-world examples. Angles of elevation and depression are formed by horizontal lines that a person's line of sight to an object form. If a person is looking up, the angle of elevation is this angle here, right? So a person standing here, angle of elevation is the one that is going up. If a person is looking down, the angle of depression is from this angle, from this person's perspective. However, angle of depression kind of throws students off. Just have to understand that when they give you angle of depression, the angle is not going to be in this upper corner that you see here. It's actually going to be outside the triangle. So, but see this angle up here, okay, geometry-wise, parallel lines with a transverse code coming across, it's going to be the same as the angle of elevation. So basically, that just feels really confusing. So what I tell students is, if they give you an angle of depression, put it in the same location of angle of elevation. It's basically the same information. But we never want to put it in this location. Okay? That's not going to be correct. The angle of depression is involving the horizontal, which is outside the triangle. So if they give you angle of depression, put it in the same location as angle of elevation. Just read it as angle of elevation. So let's look at example 3. And this will be the last problem that we do. But at least we got a head start with these word problems. Okay, a plane is coming in for landing with an angle of depression of 32 degrees. Okay. So I'm going to draw a triangle to highlight. Now, every word problem is going to be a right triangle. Okay, so you just have to kind of visualize how your diagram fits into that right triangle. So here's my plane. My plane is coming down for landing, right? So it's going to follow this path here. With an angle of depression of 32 degrees. Now, we never want to put that angle up here, so pretend like it's angle of elevation and just put it in the same spot as angle of elevation. It's always going to be in the bottom corner of your triangle. So just pretend like you're reading it as elevation. Okay, the plane is currently 3,200 feet in the air. So where do you think that 3,200 is going to go? Height, yeah, that's going to be talking about the vertical part. How far does the plane have to travel before it hits the runway? So which side are we looking for? Hypotenuse. Right. So the hardest part is just getting that diagram filled out. But once you have that diagram filled out, then it's easy, right? Either sine, cosine, or tangent. Let's see if we can finish this problem. And we'll be done for the day. And we'll spend tomorrow doing more word problems, and there's also word problems that involve a triangle within a triangle. So I think that's the hardest things. So we'll spend most of our time doing that tomorrow. Quiz is on Friday. I'll give you a quiz review worksheet for you guys to do. And I also have a morning review sheet for Friday morning, if you want to come on Friday morning to do a quiz review. All right, come on up and grab your phones. Usually I'm not going to give you homework. I just want you guys to work for the duration of class. But you're still earning credit each day for your classwork. Okay, so you guys have all earned 100 each day because I'm seeing your work. Oh, why this angle here and not here? Okay, right. Because this is how far is the plane to travel? So the plane is not traveling here. The plane is traveling here. So it's descending. So we're looking for the time of the path. The length of it, is that the same? Like exactly. Right. So when we talk about a ramp is the one that runs. So the ramp is here, it's not here. Right.